Hello and welcome to the session. In this session, we will discuss how to solve nonlinear inequalities. A nonlinear inequality is similar to a nonlinear equation, except that the equal sign is replaced by one of the following inequality signs: less than, greater than, less than or equal to, greater than or equal to. For example, x squared minus 3x is less than 1, or 2x cubed minus 3x squared plus 4x is greater than equal to 20. Nonlinear inequalities also include rational inequalities. Now we will discuss the method of solving nonlinear inequalities. We use number line analysis in finding the solution of a nonlinear inequality, and for this we follow some steps to solve inequalities. Step 1 will be set one side of the inequality equal to 0 by bringing all variable terms and constant term on the other side of the inequality. Step 2 is to factorize the given inequality into linear factors. In rational inequality, factorize both numerator and denominator. Step 3 is to find the critical points by setting each linear factor equal to 0. The next step, that is step 4, is to make a number line and plot the critical points on the number line. Step 5 is to determine the region based on these critical points. Step 6 is to test a point in each region in the factored form of the inequality to find the solution set. That is, we will check the sign of the inequality written in the factored form in step 2 to determine which region belongs to the solution set and construct a sign chart. Step 7 is to write the solution set in interval notation and graph the solution on the number line. Before we proceed further, we shall note some important points regarding nonlinear inequalities. First, if the inequality involves strictly less than or strictly greater than symbol, then the critical points will not satisfy the given inequality. So, while plotting these points on the number line, we will place a hollow circle. Second, if the inequality involves less than or equal to or greater than or equal to symbol, then critical points will satisfy the given inequality. So, while plotting these points on the number line, we will place a closed circle. The third and the most important point is, if it is a rational inequality, then critical points obtained by putting denominator equal to 0 are not included in the solution set of the inequality, irrespective of the symbol. We always place a hollow circle for these critical points. Let us consider the following example. Solve x square minus 5x greater than equal to 6. So here our first step is to set one side of the inequality equal to 0. So for this we bring constant term on other side of the inequality. That is, we get x square minus 5x minus 6 is greater than equal to 0. Step 2 is to factorize the given inequality. We have the quadratic x square minus 5x minus 6. Let us factorize it. X square minus 5x minus 6 is equal to x square minus 6x plus x minus 6. This is equal to x into x minus 6 plus 1 into x minus 6, which is equal to x minus 6 into x plus 1. So we can write x square minus 5x minus 6 greater than equal to 0 as x minus 6 into x plus 1 greater than equal to 0. Step 3 is to find the critical points. For this, we equate each linear factor equal to 0, that is, x minus 6 is equal to 0 and x plus 1 is equal to 0. So we get x is equal to 6 and x is equal to minus 1. So the two critical points are 6 and minus 1. The next step is to make a number line and plot the critical points on the number line. Let us draw a number line. This is number 6 and this is minus 1. Since 6 and minus 1 both satisfy the quadratic inequality, so because of the greater than equal to sign, we will draw closed circles on these points, which indicates that these points lie inside the solution set of the inequality. So now our next step is to determine the region based on these critical points. We draw vertical lines at these points. Now we see that the number line is divided into 3 regions. Region 1 with values less than minus 1, that is open interval minus infinity minus 1. Region 2 with values lying between minus 1 and 6, that is open interval minus 1, 6. And region 3 with values greater than 6, that is open interval 6 infinity. Our next step is to check the sign of the inequality written in factored form in step 2 to determine which region belongs to the solution set. In step 2, we obtained the inequality in factored form, that is x minus 6 into x plus 1 greater than equal to 0. Now we check the sign of LHS of the inequality for each region by choosing any point in the region. Region 1 is minus infinity minus 1. Let us choose x is equal to minus 2, which lies in this interval. We put x equal to minus 2 in the inequality x minus 6 into x plus 1 and check its sign. Minus 2 minus 6 is equal to minus 8 and minus 2 plus 1 is equal to minus 1. So, sign of x minus 6 is negative when we put x is equal to minus 2 in this factor, and sign of x plus 1 is also negative when we put x equal to minus 2 in this factor. So, sign of the product x minus 6 into x plus 1 is equal to minus into minus, which is equal to plus. So we write a plus sign on the number line for this region. Now the next region is minus 1, 6. Let us choose x is equal to 0 in this region. We put x is equal to 0 in the inequality x minus 6 into x plus 1 and check its sign, as 0 minus 6 is equal to minus 6 and 0 plus 1 is equal to 1. So, sign of x minus 6 is negative when we put x equal to 0 in this factor, and sign of x plus 1 is positive when we put x equal to 0 in this factor. So, the sign of the product x minus 6 into x plus 1 is equal to minus into plus, which is equal to minus. So, we write a minus sign on the number line for this region. Now the third region is 6 infinity. Let us choose x equal to 7 in this region. Now we put x equal to 7 in the product x minus 6 into x plus 1 and check its sign, as 7 minus 6 is equal to 1 and 7 plus 1 is equal to 8. So, sign of x minus 6 is plus when we put x is equal to 7 in this factor, and sign of x plus 1 is also plus when we put x is equal to 7 in this factor. So, sign of the product x minus 6 into x plus 1 is equal to plus into plus, which is equal to plus. So we write plus sign on the number line for this region. Our next step is to write the solution in interval notation and graph the solution on the number line. We have the inequality x square minus 5x minus 6 is greater than equal to 0. We have a greater than equal to symbol, so we will choose those regions which values greater than equal to 0, that is positive values. See, in the sign chart, we have two regions, region 1 and region 3, showing positive sign, which means these regions will satisfy the given inequality and will form the solution set. Also, critical points are included in these regions because we have greater than or equal to 0. So, the solution set in interval notation is given by minus infinity minus 1, which is open at minus infinity and closed at minus 1, union 6 infinity, closed at 6 and open at infinity. Now to graph the solution on the number line, we darken the number line from minus 1 to minus infinity and 6 to infinity with closed circles at -1 and 6. This is the required graph of the solution set. Note that if the given inequality was of the type x square minus 5x minus 6 greater than 0, then we would not have included -1 and 6 in its solution set because it is strictly greater than inequality. Then its solution set will be open interval -infinity -1 union open interval 6 infinity. And on the number line, we will keep hollow circles at -1 and 6 and will darken the line from -1 to -infinity and from 6 to infinity. So in this session, we have discussed how to solve nonlinear inequalities. This completes our session. Hope you enjoyed this session.